Let's do some of these, or let's just at least talk about it. Okay, you want specifically D? You want to know if it's even, odd, or neither? Okay, if the problem only asks if the function is odd or even, that is only the negative x test. That is only the negative x test. That means you just plug in a negative x, see if you get the same thing, see if you get the exact opposite, or if you get nothing, neither. Okay, if you get the same thing, then it's even. So if we get the same result, then we know we're even. If we get exact opposites, that's odd. Now, if we want to talk about symmetry, the negative x test does help find symmetry about the y-axis and symmetry about the origin. It does not help us with symmetry about the x-axis, in which case you have to do something different. I guess since I'm talking about symmetry, let's go ahead and talk about it. Okay, if you plug in an x and you get y, and you plug in a negative x and you still get y, what is this symmetry about? This is y-axis. And that makes sense, because if you look at a graph like x squared, which has symmetry about the y-axis, if I plug in x, I get y, and if I plug in negative x, I get the same y. So that's symmetry about the y-axis. If you plug in x and you get y, and then you plug in x and you get negative y, what is that? That's symmetry about what? What? This is symmetry about the x-axis. I'm going to use a parabolic shape again to illustrate what I'm talking about. If I have a non-function, this is a non-function because it doesn't pass the vertical line test, and if I plug in x, I get a y, a positive y, and I get a negative y. So if I were to test for x-axis of symmetry, I have to plug in a positive y and a negative y to see if I get the exact opposite. Okay? Or I'm sorry, to see if I get the same x value, not those opposites. So I would plug in y. Well, I guess I don't need to plug in positive y. You would just plug in negative y to see if you get the same thing. And if you get the same thing, you know you have symmetry about the x-axis. What's the only other symmetry that we haven't talked about? Origin. And we know that if we plug in negative x and we get the opposites, then that means we have symmetry about the origin and we have an odd function. So let's say if we plug in x, we get y, but then when we plug in negative x, we get negative y. That is symmetry about the origin. But this isn't talking about symmetry. It's saying, is it even, odd, or neither? Okay, so let's plug in a negative x to that d. So we have negative x raised to the 7th. Okay, if we raise it to the 7th in odd power, then we're just still going to stay negative. And now I have a question. Is this the exact opposite, or is it the same? Yeah, this is definitely a neither. It's not the same. It's not the exact opposite. So this is a neither problem. Yeah. It really helps if you know what this guy looks like. And because we're shifting to the left, I don't know. Or that's to the right. Shifting to the right, it changes it. Okay. Here, let's talk about what this looks like since we're at it. X to the 7th would look like this. It almost looks like x to the 3rd, except when we subtract 1, that's going to shift this whole thing down 1. Right? So it would be down here. But then when we put these absolute value bars right here, something else changes. Instead of all this stuff being down here, it's going to be up. So it's going to go... Oh, man. How would I do that? See, so I just took whatever was below the x-axis and I folded it upwards. It looks pretty wacky, huh? And then because of this -1, I'm going to then move it down 1 again. Well, that's really confusing. I'd rather just plug in a negative x. Wouldn't you? So let's try C. If I plug a negative x to this one, I would get a negative x to the third power. If I plug a negative x to that one, that would be a positive x. And then the plus 1 would stay the same. Now look at this, and look at what we started with. Are they the exact opposite? No. They're almost the exact opposite. Look, this plus 1 jacks it all up. This is the opposite. This is the opposite. But then that plus 1 stays plus 1. So they're not the exact opposite. Neither are they exactly the same. So this would be neither. Let's do this problem again, but let's get rid of that 1. Okay, so let's say that 1 wasn't there. Whoops. Okay, the 1's not there. Okay, yay. When I plug in negative x to this one, I get negative x to the third. When I plug in negative x to this one, I get positive x. Look at that. Exactly the opposite. This is exactly the opposite of that. Therefore, this is odd. Origin of symmetry.